Greetings. Today we have another limit question. It's a pretty crazy looking limit. Wait, is this echoing? Okay, wait. Okay, hopefully that's not echoing anymore. What do we do with this limit? Well, firstly I want to expand this part out. Wait a minute. Okay, wait. This was meant to be x, not n. Okay, my apologies. Anyway, so first I want to expand this part out as 2 to the x times the absolute value of sine x to the x to the x. Wow, okay. Now what? Well, we might just have to sneakily set up a squeeze theorem sort of thing again, because we have a sine function and honestly this looks pretty cooked if we don't do squeeze theorem. So we need to set up an inequality. We know the sine function is bounded between -1 and 1, but I mean we have absolute value, right? So we can say the absolute value of sine x to the x would be between 0 and 1. Great, so now we just want to write the limand, set up an inequality for the limand. Bro, that should be a term. I don't know why it's not a real thing. We can raise both sides to the x power, which I think is fine, right? Because, yeah, everything's positive. Should be fine, hopefully. Now we multiply by 2 to the x, which is positive, so no inequality sign changing. Then we add 3 to the x to both sides. Okay, so that should be fine. Now we need to take the xth root, which is just raising to the 1 on x power, right? Okay, so we can take the xth root of this part, and then the xth root of this part, and then the xth root of this would just be 3, right? Because 3 to the x times 1 on x. Great. Now we want to take the limit as x goes to infinity, but we need to deal with this limit on the right side, I guess. Okay. So we have the limit of the xth root of 3 to the x plus 2 to the x. How do we do this? Okay, we can write this as this thing to the 1 on x power, and then maybe we just make the base e, because e is objectively the best base for calculus. So e to the ln of this thing, and then we take the 1 on x down, and because e to the something, the exponential function, is continuous, you can actually write this as e to the limit of that thing. So that's like a rule about limits. If you have a limit of a continuous function, you can just switch the limit and the function, if you know what I mean. Great, so this thing is going to be going to infinity, right? The top goes to infinity, the bottom goes to infinity. So we can use L'Hopital's rule, where we differentiate the numerator and denominator. And if this resulting limit exists, then we can say that they're equal. Okay, so we'll just differentiate the top. That would be something like this, and then 3 to the x log 3, right? Plus 2 to the x log 2, okay. And then when you differentiate x, we're just going to get 1. So we don't really need that denominator. Yeah, so I'll just put this over here. Now we need to deal with this limit. Maybe we just look at the fastest growing term, which is 3 to the x. It'll probably just be log 3, but the answer, but let's just divide by 3 to the x to make sure. Okay, so if you divide by 3 to the x, you get this. Okay, so the 2 on 3 is just less than 1, right? It's 0.66 recurring. And that's going to go to 0. Something less than 1 to the x as x goes to infinity would be 0. So we just have log 3 plus 0 over 1 plus 0. And okay, yeah, so that is log 3. Nice. So we have e to the log 3, and that would just be 3. And I guess the squeeze theorem worked out, because now both of these sides go to the same limit. So by the squeeze theorem, we can say that our original limit, which is this crazy thing, is 3. Thanks for watching. I was going to say I'll see you next time, but I say that in every video, so I don't know. I don't know how to end this. Okay, bye.